Hello everyone. Now I'm gonna demonstrate a Kafka Avro-based order pipeline, which developed for one of our big data module assignments. So the assignment requirement was to build a Kafka-based system using Avro messages with real-time aggregation and retry logic for temporary failures and dead letter queue, which DLQ for permanently failed messages. So I have implemented this as three main components. The first one is React UI, and the second one is Spring Boot producer service, and the third one is Spring Boot consumer service, plus with shared neural model. So let's see high-level architecture. So here you can see the high-level architecture. So first we have order UI, with orders UI. The React, it is a React tab where I can create orders and view stats. So the second is a order producer service. It is a Spring Boot REST API. So the UI sends JSON orders to this service, and it converts them into ordering messages and publishes them to Kafka topic. And the topic is called orders. And the third order consumer service, it is one of the Spring Boot tab that consumes from the orders topic. In here serialize the order messages, and update is running static like total and average price and these errors. So if messages fail processing after retry, they go to the dead letter queue topic, which order.dlq. So which the consumer also reads the exposed DLQ entries via the REST API, and all services share the same schema from a common module called order module. Let's see the codes. So at the root, we have the order module with a schema, and the orders producer service, then the order consumer service, and finally the orders UI component, and also there's a local file there for the Kafka. So yeah, this is the schema the whole system is based on. So it defines an order record with the order ID and product and price as a float. So let's say the producer key code. Yeah, in here the REST controller API orders. It can set a JSON order request and validates and passes into the producer service. So this class build an Avro order object. So serialize to bytes and send to the Kafka order topic. So it also stores a small list of recent orders in memory, so the UI can show them. Now let's see the consumer key code. So this Kafka listener reads from the orders topic and deserialize our payload and passes the order to the static services. And also simulate failures actually with the product name equal fail. I throw an exception and then Spring Kafka retries, and if it still fails, the message is sent to the DLQ topic as a DLQ topic. So a second listener read from orders.dlq topic and records DLQ entries. So this class maintains counts and total prices and running average using atomic counters and a small in memory list of recent DLQ events. So let's see the UI code. So yeah, the React app has a form of to create orders, and it periodically calls three endpoints: produce a API, produce a API orders, JSONs, and consume API stats, and API DLQ to display live stats and DLQ messages. That's Kafka and the server. So first I start using the template. So this starts a single node Kafka worker or port 1992. So once Kafka is running, I create two topics orders per DLQ. Actually, I have already done that, but the commands are in the CP file. You can see here we can check. Here we have orders. Orders per DLQ. So then let's build and run the backend. So actually now here we are using the backend. So I use the Maven wrapper, so there's no need to install Maven globally. Build successfully. So then let's put the orders. Produce a and start. So as you can see, the producer size is labeling on port 8081, and the consumer services need to run. So let's run internal 2. Now the consumer services running port 8082 from the UI. Let's say the UI. This is the orders dashboard. So on top is the order creation form, and then the below I show recent orders sent by the producer, and the consumer stats and PFQ entries you can see. And now I will send a few more orders like 01 about yeah. You can see it sends to the consumer. So let's try another one. Yeah, you can see the recent orders appear here. Today it's coming from the producer's API, and on the consumer side, the orders consumer services running each Avro messages from Kafka and deserializing it, and then updating the statistics. So here you can see from the count storage price and storage price updating as I send orders. Now I will send an order with product name fail. In my consumer code this actually triggers an exception to similar processing failure. So let's see. Yeah, as you can see, this Spring Kafka automatically retries this message a few times, and then this if it is still fails, it publishes the report to the DLQ public named orders.dlq. Yeah, you can see that the order has now appeared in the DLQ entries along with the reason and timestamp. So at the same time, the DLQ counter in the stats is also increased to 0 to 1. So we have seen that the JSON order from the UI is going to the Avro messenger on Kafka, and then the consumer processing and integration. So for normal messages, they contribute to the running stats, and for failing messages, retries attempt, and then they ended up the DLQ. So that's all. Thank you.